Gradient descent is a tool for robotics, computer games, and mechanical engineering. Its cost efficiency makes it the algorithm of choice. Jordan Ellenberg, a mathematics professor at the University of Wisconsin-Madison, calls it ridiculous in the human sense, but perfect for machine learning. Let us tell you all about how the gradient descent algorithm works. What is gradient descent? We will give a real-life example in a moment, but the textbook definition goes, it is an iterative first-order optimization algorithm that is used to find a local minimum of a function. In non-technical language, you find the parameters of a function with the lowest value. However, the function does not always find the global minimum. Sometimes the coefficients found are at a local minimum. Gradient descent in machine learning minimizes the cost function. Due to its ease of implementation, this algorithm is usually the first thing taught in all machine learning courses. Despite this fact, gradient descent is widely famous in other technology areas like computer games, control engineering, and mechanical engineering. One approach to this analyzes each error in the dataset. This provides the most efficient results. We will talk about batch gradient descent shortly. But first, let us explain it with real-life examples. Imagine you are at the top of a mountain and want to reach your peers at the base. However, that is the lowest point of the mountain. As well, the weather is bad and the area is foggy. Thus, visibility is low and your path is unclear. How do you reach the base to meet your friends? For one, you can use your feet to determine the path that descends. This helps with knowing what direction is steep and must be avoided. If you follow the descending path until you encounter a flat ascending path, you could easily make it to the base. However, what if there is a slight rise in the ground when you go downhill? You would immediately start assuming that you reach the base, also known as the global minimum in this scenario. However, in reality, you are still somewhere on the mountain or local minimum. Gradient descent is therefore the deepest downward slope algorithm. It is essentially the best prediction model in data analysis for cost minimization. Now, there are three types of gradient descents. Let us take a look at them. Number 1. Batch gradient descent. A batch gradient is also known as a vanilla gradient descent. Batch descent is beneficial because of its computational efficiency. It develops a stable error gradient descent to calculate the error for each example in the training dataset. Nonetheless, it calculates it after each training example has been evaluated. This repeating cycle is often referred to as training error. On the other hand, batch gradient descent has a few drawbacks. Sometimes, the stable error gradients can lead to a convergence state that complicates things. Additionally, it needs the training dataset in its algorithm and memory at all times. When you combine the efficiency of this approach and the robust nature of stochastic gradient descent, or SGD, you will arrive at the mini batch gradients. Both are coming up next. Number 2. Stochastic gradient descent. You have subscribed to our channel for everything about machine learning, correct? If not, now is your chance. Now, the SGD offers individual parameter updates for each training example. It pays attention to each example, ensuring that the process is error-free. The method is faster than batch gradient descent, depending on the problem. The regular update provides detailed improvement rates too. Meanwhile, these updates are expensive, especially when compared to other methods. In addition, the frequency of updates can cause noisy gradients that prevent the error rate from decreasing. Rather, the error rate increases and becomes problematic in the end. Jordan Ellenberg illustrates it in his 2021 book, Shape: The Hidden Geometry of Information, Biology, Strategy, Democracy, and Everything Else. He said, "What I like about stochastic gradient descent is how nuts it sounds. Imagine, for instance, that the President of the United States made decisions without any kind of global strategy. Rather, the nation's chief executive is surrounded by a crowd of shouting subordinates, each hollering for policy to be tweaked in a way that suits their own particular interest. And the president every day chooses one of these people at random to listen to and changes course accordingly. That would be a ridiculous way for a person to run major world governments, but it works pretty well in machine learning." Number 3. Mini batch gradient descent. The mini batch gradient descent is a perfect blend of stochastic and batch descent concepts. It divides datasets into batches and performs an update for each batch. This combined approach provides the best of both worlds. Hence, scientists use mini batch gradient descent as a starting method, and people use it as the default option for training neural networks. Finally, this is how gradient descent works. First, choose a starting point. That is called your initialization. Next, calculate the gradients at this point. Next, make a scaled step in the opposite direction to the gradients. The apparent objective is to minimize. Then, repeat points 2 and 3 until one of the two criteria is met. Either the maximum number of iterations reached or the step size becomes smaller than the tolerance. That is how to implement the gradient descent algorithm for optimizing cost. Any questions? Ask away in the comments. Hopefully other machine learning enthusiasts will connect with you. Still on machine learning, here are 5 methods to handle imbalanced data. Top 5 ways on how to work imbalanced data learning.